The 14th chapter in 10th standard maths is probability. So in some states textbooks the chapter number could be different, it could be 5, chapter 5 or chapter 10, but all states who have implemented national education policy will have the same syllabus. So even the chapter number is different, and if your state has implemented national education policy, you can use this video for learning purpose. If I ask you what is the chance of getting a head or a tail when we toss a coin, you would say that it's 50-50, right? Anybody would answer the same. So how do we explain this? How do we define this mathematically? That's the question. In maths, in the topic probability, we define this tossing of coin as an experiment. Okay, tossing of a coin is an experiment, and when we do an experiment it will have some result. So when we toss a coin, it will give head or tail as result. I have represented that as H and T. So these are the two possible result or the outcomes when we toss a coin. So the number of possible outcomes in this experiment is 2. Similarly, in throwing a dice experiment, so you know that the dice has 6 faces and each face will have a number on it. And when we throw a dice, what is the result of that experiment? See, the face facing towards top, that is the result, and whatever number is there on that face, that is the result. So when we throw a dice, the result could be 1, 2, 3, 4 or 5. So these are the possible result or the possible outcomes of this experiment. Okay, and the total number of possible outcomes are 6. Event of an experiment. Event of an experiment is simply defined as an outcome of an experiment. For example, when we toss a coin, we may get a head or a tail. So getting a head is an event. Similarly, getting a tail is an event. And in throwing a dice experiment, when we throw a dice, we may get odd number or we may get even number. Okay, so getting an odd number is an event. Okay, also getting an even number also is an event. Also getting numbers less than 5 is an event. Also getting numbers more than 3 is also an event. Probability of an event is simply denoted as P of event, and this is simply equal to ratio of number of favorable outcomes by number of possible outcomes. So for example, in tossing of a coin experiment, if H is the event of getting a head, then probability of getting a head is denoted by P of H. So going by standard definition, it is the ratio of number of favorable outcomes by number of possible outcomes, right? So P of H is equal to, so in the denominator number of possible outcomes are there. So in tossing of a coin experiment, you can see here the number of possible outcomes is 2. So in the denominator it is 2, and the number of favorable outcomes, so this can be found using possible outcomes. So in possible outcomes, the outcomes are head and tail. So how many heads are there? Just one. That's why it is 1 by 2. So 1 by 2 is equal to 0.5. Similarly, what is the probability of tail? Going by standard definition, it is simply number of favorable outcomes by number of possible outcomes. So as in the previous case, the number of possible outcomes is 2. So here in the denominator it is 2. So what is the number of favorable outcomes? So possible outcomes are head and tail. So how many tails are there here? Just one. That's why here also it is 1 by 2. 1 by 2 is equal to 0.5. And probability of head plus probability of tail is equal to, you can check it out, it is 0.5 plus 0.5, which is equal to 1. In a coin tossing experiment, if H denotes an event of getting a head and T denotes an event of getting a tail, then in the previous page we already came to know that the sum of the probability of getting a head and a tail is equal to 1. Okay, therefore these two events are called complementary events. That is, an event of getting a head and an event of getting a tail are complementary events, because these two events cannot occur simultaneously. Whenever we get head, we won't get tail, and whenever we get tail, we won't get head. Okay, that's why these two events are called complementary events, and the sum of the probabilities of the complementary events is equal to 1. Okay, and if H is an event of getting ahead, then not H, okay, not H or H bar, it is read as not H only, then not H is an event of not getting ahead. Okay, therefore probability of getting ahead and probability of not getting ahead will be equal to 1. So therefore here H and not H are complementary events. Coming to dice throwing experiment, here what are the possible outcomes of this experiment? So when you throw a dice, you get outcome as 1, 2, 3, 4, 5 or 6. So these are the 6 possible outcomes. Okay, now what is the probability of getting an even number? So according to the standard definition, the probability of an event is defined by number of favorable outcomes by number of possible outcomes. So in this experiment, what is the number of possible outcomes? It is 6, because you can count and check 1, 2, 3, 4, 5, 6. So there are only 6 possible outcomes in a dice throwing experiment. And what is the number of favorable outcomes? So we need even numbers. So how many even numbers are there? 2, 4 and 6 are the even numbers. Therefore there are 3 even numbers, 2, 4 and 6. So 3 by 6 gives 1 by 2. So 1 by 2 is the probability of getting an even number in a dice throwing experiment. Similarly, what is the probability of getting an odd number in this experiment? So going by standard definition, number of favorable outcomes by number of possible outcomes. So number of possible outcomes is 6 only. Okay, so number of favorable outcomes. So how many odd numbers are there here in this one? So 1, 3 and 5. Totally there are 3 odd numbers. So 3 divided by 6 gives 1 by 2. Therefore 1 by 2 is the probability of getting an odd number in a dice throwing experiment. Similarly, what is the probability of getting 8? Okay, so going by standard definition, number of favorable outcomes by number of possible outcomes. So number of possible outcomes is 6. Here also it is 6 only. Okay, there are 6 possible outcomes in a dice throwing experiment. And what is the number of favorable outcomes? So here it is 0, because no matter how many times you throw dice, you get 1, 2, 3, 4, 5 or 6. You will never get 8. Therefore favorable outcomes will be equal to number of favorable outcomes will be equal to 0. So 0 by 6 gives 0. So whenever the probability of an event is 0, then we call that event as an impossible event. So getting 8 in a dice throwing experiment is an impossible event. It can never happen. Okay, and what is the probability of getting a number which is less than 7 in this experiment? So going by standard definition, so here also going by standard definition, the probability is given by number of favorable outcomes by number of possible outcomes. So what is the number of possible outcomes here? It is 6 only. And number of favorable outcomes. So whenever you throw a dice, you get outcomes 1, 2, 3, 4 and 5, and all these are less than 7. Therefore totally there are 6 outcomes which are less than 7. Therefore 6 by 6 gives 1. So whenever the probability of an event is equal to 1, then we say that event is an sure event or a certain event. In this dice throwing experiment also, you can observe that if we add the probability of an event of getting an even number and the probability of an event of getting an odd number, we get this equal to 1. So that's why these two events are complementary events, because whenever we get odd numbers, we don't get even number. Whenever we get even number, we won't get odd numbers. That's why these two events, that is event of getting an odd number and an event of getting an even number, are complementary in a dice throwing experiment. Elementary event. An event having only one outcome of the experiment is called an elementary event. For example, in a coin tossing experiment, what are the possible outcomes that we can have? Head and tail, right? So total number of possible outcomes is 2. Now the probability of getting a head is given by number of favorable outcomes divided by number of possible outcomes. So number of possible outcomes is 2. Head and tail, 2 outcomes are there. So in the denominator 2 will come, and in the numerator number of favorable outcomes. So here number of favorable outcomes is number of heads. So out of these two outcomes, how many heads are there? Just only one head is there. So 1 by 2. Since only one head is there, we can say the event of getting a head is an elementary event. Okay, and the probability of getting head, here it is 0.5. Okay, 1 by 2 is 0.5. Similarly, what is the probability of getting a tail? Again, here going by standard definition, it is the ratio of favorable outcomes by possible outcomes. So number of possible outcomes is 2. Favorable outcomes is nothing but the number of tails. So out of these two possible outcomes, how many tails are there? Just only one tail is there. Therefore 1 by 2. Since only one tail is there, we can say that an event of getting tail is also an elementary event. Okay, so the probability of tail also is equal to 0.5. 1 by 2 is 0.5. Now if we add these two probabilities, probability of head plus probability of tail is 1 by 2 plus 1 by 2 is equal to 1. Therefore we can conclude that the sum of probabilities of all the elementary events of an experiment is equal to 1. Not only in this experiment, take any experiment, the sum of the probabilities of the elementary events will be equal to 1. In a coin tossing experiment, the event of getting a head and the event of getting a tail, they are complementary events as well as they are elementary events. But this may not be the same case in all other experiments. Let us go through some worked example in the textbook. So here in the textbook, you can see the probability of an event E is given as number of outcomes favorable to E divided by number of possible outcomes of the experiment, or simply probability of an event is equal to the number of favorable outcomes by number of possible outcomes. So here in example 1, you can see this is a coin tossing experiment. In a coin tossing experiment, what are the possible outcomes that we can get? Head and tail. These are the two possible outcomes that we can get in a coin tossing experiment. Therefore probability of head is equal to number of outcomes favorable to E. That means number of favorable outcomes here is number of heads. Okay, so here in these two outcomes, how many heads are there? Only one head is there. Therefore 1 divided by number of possible outcomes is 2. Head and tail, two outcomes are there. So 1 by 2. Similarly, probability of tail is equal to 1 by 2, because out of these two outcomes only one tail is there. Therefore 1 by 2 is the probability of tail. Now here they have considered E as an event of getting head, and F they have taken as event of getting tail. Instead of E and F, you can take any other alphabet. That's not an issue at all. Or you can give some meaningful words, or a small sentence like this. Here you can see probability of head, probability of tail. Like this, if you give like this, anybody who reads this also will be able to understand it very easily. And as I told you, an event having only one outcome of the experiment is called an elementary event. So in a coin tossing experiment, an event of getting head and an event of getting tail, they are elementary events, and when we add the probability of the elementary events, we will get equal to 1. The sum of probabilities of all the elementary events of an experiment is 1. And here in example 3, there is a dice throwing experiment. So in a dice throwing experiment, what is the probability that we get a number which is greater than 4? Okay, so out of these possible outcomes, there are 6 possible outcomes: 1, 2, 3, 4, 5 and 6. So how many numbers are greater than 4? 5 and 6. There are 2 numbers which are greater than 6. Therefore probability of getting a number which is greater than 4 will be equal to 2 divided by 6, which is equal to 1 by 2. Similarly, what is the probability of getting a number which is less than or equal to 4. Okay, see here, probability of an event getting less than or equal to 4. So in this possible outcomes, how many numbers are there which are less than or equal to 4? 1, 2, 3 and 4. There are 4 numbers which are less than or equal to 4. Therefore probability of getting a number which is less than or equal to 4 will be equal to 4 divided by 6, which is equal to 2 by 3. And I told you that if there are two events which are complementary to one another, then the sum of their probabilities will be equal to 1. If E is an event and not E is its complementary, then probability of E plus probability of not E is equal to 1. Now here again, coming to the dice throwing experiment, what is the probability that we get a number 8? We won't get number 8 at all. No matter how many times we throw the dice, we get numbers which are always less than 7. Okay, therefore probability of getting 8 is equal to 0 by 6, which is equal to 0. So this is an impossible event. And what is the probability of getting a number which is less than 7? It is equal to 6 by 6, which is equal to 1. So this is the sure event. So this one I already explained you. Okay, you can see here, probability of getting a number, probability of getting 8 is equal to 0. This is an impossible event. Probability of getting a number which is less than 7 is 1. This is a sure event or a certain event. And what is the probability of getting an even number? Probability of getting an even number is 1 by 2, and probability of getting an odd number is 1 by 2. So these two events are actually complementary events, because whenever we get odd number, we won't get even number, and whenever we get even number, we won't get odd number. Therefore probability of getting even number plus probability of getting odd number in a dice throwing experiment is equal to 1 by 2 plus 1 by 2 plus 1 by 2, which is equal to 1. And probability of an event is always greater than or equal to 0 and less than or equal to 1. Okay, so in this textbook there are several examples, and they have explained it in very simple language. Just go through it. All are very easy. First time you may not understand, but when you read it again and again, you will be able to understand. So you should make this a habit. So tomorrow when you are doing higher studies, and if you miss 1 or 2 class, you will be able to read textbook by yourself and understand everything. So now only you should make reading textbook a habit. I will be solving only the exercise problems. Exercise 14.1, question number 1. Complete the following statement. Probability of an event E plus probability of the event not E is equal to 1. In the previous page you can see that the event of getting head and the event of getting tail, these two are complementary events. Why? Because these two events cannot occur simultaneously. Whenever we get head, we won't get tail, and whenever we get tail, we won't get head. And the probability of head is 1 by 2, probability of tail is 1 by 2. When we add these two probabilities, we get equal to 1 by 2. Okay, and if probability of head is represented by P of H and probability of tail is represented by P of T. Okay, P of T I can also represent by P of not H. Okay, therefore probability of H plus probability of not H is equal to 1, or in general probability of an event E plus probability of not E is equal to 1. Second sub question, the probability of an event that cannot happen is 0. Such an event is called impossible event. Again, if you come to the previous page, you can see here, in a dice throwing experiment, the possible outcomes are 1, 2, 3, 4, 5, 6, and in this experiment, can we get number 8? No. So probability of getting number 8 is equal to 0. Okay, here going by definition, number of favorable outcomes divided by number of possible outcomes. Possible outcomes in a dice throwing experiment is 6, because 1, 2, 3, 4, 5, 6 outcomes are there. And out of this, is there any 8 here? Definitely no. There are 0 8s here. So 0 by 6 is equal to 0. So whenever probability of an event is equal to 0, then we call that event as impossible event. Sub question 3. The probability of an event that is certain to happen is 1. Such an event is called sure event or certain event. Again, if you come to the previous page, you can see that in a dice throwing experiment, what is the probability of getting number which is less than 7? Okay, see here, I have written here, probability of an event getting less than 7 is equal to 1, because going by standard definition says that probability of an event is given by number of favorable outcomes by number of possible outcomes. So in a dice throwing experiments, what are the number of outcomes? 1, 2, 3, 4, 5, 6. So in the denominator it is 6, and whenever we throw the dice, always we get numbers which are less than 6 only. Therefore possible favorable outcomes will be 1, 2, 3, 4, 5, 6. So 6 divided by 6 is equal to 1. So whenever we get the probability of an event equal to 1, then that event is called a sure event or a certain event. Sub question 4. The sum of the probabilities of all the elementary event of an experiment is 1. So here elementary events already have explained. In a coin tossing experiment, the event of getting head and the event of getting tail, they are two elementary events. Okay, probability of head is 0.5, probability of tail is 0.5. When we add the probabilities of these two, we get equal to 1. And in any experiment, the sum of the probabilities of all the elementary events is equal to 1. So in coin tossing experiment also, when we add the probability of getting head and the probability of getting tail, will get equal to 1. Fifth sub question, the probability of an event is greater than or equal to 0 and less than or equal to 1. Okay, so in general, if E is an event, then probability of that event is always greater than or equal to 0 or less than equal to 1. This is true for any experiment, whether it is a coin tossing experiment or a dice throwing experiment or any other experiment. Probability of an event always will be greater than or equal to 0 and less than or equal to 1. And that completes question 1. Exercise 14.1, question number 2. Which of the following experiments have equally likely outcomes? Explain. A driver attempts to start a car. The car starts or does not start. See, when the car will not start, when there is no fuel or the battery is down, or when there is some other issues like some wire has got cut, only in those times the car will not start. Okay, but if the condition of the car is good, then always whenever the driver will attempt to start it, it will always start it. Okay, therefore the event that the car will start or not, the car will not start, they are not equally likely. It is likely to start always if the condition of the car is good. Okay, then the next sub question, a player attempts to shoot a basketball. She or he shoots or misses the shot. See, the professionally trained players, they'll have enough practice, okay, enough training they'll have, that most of the times when they get the ball, they're likely to shoot it. Okay, out of 10 times, probably 8 to 9 times they'll be able to shoot it. Okay, so the probability that the event that they're likely to shoot or not likely to shoot, they're not equally likely. And the third sub question, a trial is made to answer a true-false question. The answer is right or wrong. Suppose if the subject is known, then we'll be answering most of the questions right. But if we don't know the subject, if it is just a guessing kind, then the chances that half of them will be able to guess it correct, and half of the question will be guessing wrong. Okay, therefore answering it right or wrong, it is equally likely to occur. The fourth sub question, a baby is born, it is a boy or a girl. See, already on earth there are 50% of males and 50% of females. Okay, therefore the next baby which is born also, it may be boy or girl, we can't say. So there are 50-50 chances. Therefore the next baby born will be a girl or a boy, they are equally likely to occur. And that completes question number 2. Exercise 14.1, question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? So in a tossing of a coin, what are the possible outcomes? Possible outcomes are head and tail. Okay, now what is the probability of head? What is the probability of getting a head? So this is equal to so this is number of favorable outcome by divided by number of possible outcome. So this is the definition for probability of an event, right? Favorable outcome by possible outcome. So what is the number of possible outcome? Here it is 2. So only head and tail can occur. And what is the favorable outcome? So in this one, head occurs only once. That's why 1. Okay, 1 by 2. So this is 0.5, right? So in a tossing of a coin, probability of a head is 0.5. Similarly, probability of tail occurring. Okay. Similarly, probability of tail occurring will be 1 by 2, which is equal to 0.5. Okay. Probability of head is equal to probability of tail. Therefore, they are equally likely. Okay. Therefore, head and tail are equally likely to occur. Okay, and that's why it is a fair way of deciding which team should get the ball at the beginning of a football game. Not only in football game, in any other game, this is a fair method. Okay. Exercise 14.1, question number 4. Which of the following cannot be probability of an event? So A is 2 by 3, B is minus 1.5, C is 15%, and D is 0.7. So here it is B. Okay, B, answer is B. Now probability is simply the ratio of favorable outcome by possible outcomes, right? Okay, and this ratio is less than or equal to 1 and greater than or equal to 0, right? Now what is 2 by 3? 2 by 3 is actually less than 1. Okay, and what is 15%? Okay, 15% means it is 15 by 100. So 15 by 100 is 0.15. So again this is less than 1, and 0.7, again this is less than 1, greater than 0. So this also, it's greater than 0. Then 0.15 also is less than 1 and greater than 0. But what about minus 1.5? Okay, minus 1.5. See, probability of an event can't be negative. That's why B is the answer for this question. Probability of an event can be always positive. It varies from 0 to 1. Okay, D. Probability of an event is always positive. and varies between 0 and 1. Exercise 14.1, question number 5. If probability of E is equal to 0.05, what is the probability of not E? So we know that probability, the sum of probability of an event and its complement is equal to 1. Okay. Therefore now what is probability of not E is equal to 1 minus probability of E. Now what is probability of E? It is given as 0.05. Now 1 minus 0.05, so it is 5. Then 9 minus 0 is 9, so 0. So this is 0.95. Probability of not is 0.95. Says 14.1, question number 6. A bag contains 11 flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavored candy or lemon flavored candy? Okay. Bag contains what? Bag contains only lemon flavored candies only. Okay, candies only. Now Malini takes one candy out of that. Okay, so when she takes out, what is the probability that an orange candy will come? Okay, so it is 0 because only lemon candies are there. So no matter how many times she tries, she will get a lemon candy only. She won't get an orange candy. That's why probability of orange is 0. And what is the next question? A lemon flavored candy. So here this is an event of getting a lemon flavored. Okay, lemon flavored. So only lemon flavored candy is there inside the bag. So whenever she picks, she gets lemon flavored candy only. Therefore probability of lemon will be equal to probability of an event where lemon candy is picked up is 1. Okay. Now the first one, this is actually a impossible event and this is a sure event. This is not necessary to write. Just for your understanding I am writing. Exercise 14.1, question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. Okay, what is the probability that 2 students have the same birthday? So given that probability that 2 students not having same birthday. Okay, not having same birthday. So probability of this event, it is given as 0.992. Now probability of 2 students not having same birthday plus probability of 2 students having 2 students having same birthday. See, these 2 events are complementary events. Okay, now this should be equal to 1. Okay, In the first case, the event is two students not having same birthday. In the second event, two students having same birthday. So they are complementary to one another. So the sum of their probability should be equal to 1. Therefore, now what will be the probability? Probability of two students having same birthday. Same birthday. This will be equal to 1 minus probability of two students not having same birthday, right? So this is equal to 1 minus, so probability of two students not having same birthday, it is given as 0.992. so what is 1 minus 1 minus 0.992? so this is equal to 0.008. so 0008. therefore the probability of two students having same birthday is 0.008. Exercise 14.1, question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? So here number of red balls is equal to 3. Okay, it's given data. And number of black balls is equal to 5. Therefore total number of balls is equal to 3 plus 5 is equal to 8. Okay, and now what is the probability of picking a red ball? So there are 8 balls and one ball is picked, so the probability of picking a red ball will be equal to number of red balls divided by total number of balls. Okay, so this is equal to 3 divided by 8. So this is the first sub question here, and in the second sub question, what is the probability of not drawing a red? Okay, now drawing a red ball and not drawing a red ball, they are complementary events. Therefore probability of red and plus probability of not red is equal to 1. These two are complementary events. Now probability of not red is equal to 1 minus probability of red. Okay, so this is equal to 1 minus probability of an event drawing a red ball is 3 by 8. so this is equal to 1 means 1 by 1, so LCM of 1 and 8 is 8. so 8 by 8 minus 3 by 8 is equal to 8 minus 3 is 5 by 8. Exercise 14.1, question number 9. A box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be a red, white and not green? So here number of red marbles is equal to 5, and similarly the number of white marbles is equal to 8, and green marbles are 4 in numbers. So they total up to 8, 16 plus 1 17. So totally there are 17 marbles. Okay, therefore now the probability of picking a red marble will be equal to number of red marbles by number of total number of marbles. So this is equal to, number of red marbles is 5, total marble is 17. Okay, both are prime numbers, it can't be simplified, so leave it. Now what is the probability of picking a white marble? So here also it is number of white marbles divided by total number of marbles. So this is equal to, what is the number of white marbles? 8. Total number of marbles is 17. Now we should find the probability of picking a not green marble. Okay, before that we'll find probability of picking a green marble. Probability of picking a green marble will be equal to 4 by 17. 4 is the number of green marbles, so 4 by total number of marbles is 17. Therefore 4 by 17 is the probability. Now probability of picking a green marble and probability of picking a not green marble are complementary events. Therefore when we sum the probabilities of these two, it will be equal to 1. Okay, therefore probability of not green will be equal to 1 minus probability of green. So this is equal to 1 minus probability of green is 4 by 17. So now LCM of 1 and 17 is 17. So 17 minus 4 I will get 13. So this is equal to 13 by 17. So probability of an event where a green marble is not picked is 13 by 17. Exercise 14.1, question number 10. A piggy bank contains 100 50 paisa coin, 50 1 rupee coin, 20 2 rupee coins and 10 5 rupee coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin, will not be a 5 rupee coin? So this piggy bank contains many coins, 50 paisa coins, 1 rupee coins, 2 rupee coin and 5 rupee coin, and it is turned upside down. So when it is turned upside down, one coin will fall, and they are asking what will be the probability that a 50 paisa coin will come out, and what is the probability that a 5 rupee coin will not come out. That's the question. So here, what is the number of 50 paisa coin? 50 paisa, right, 50 paisa coin. So this is equal to 100. And what is the number of 1 rupee coin? So number of 1 rupee coin is equal to 50. And what is the number of 2 rupee coins? Number of 2 rupee coins is equal to 20. And number of 5 rupee coin, is equal to 10. Okay, therefore total number of coins is 100, 150, 170, 180. Okay, therefore when we turn the piggy bank upside down, okay, one coin will fall out, and now the probability that a 50 paisa coin, okay, 50 paisa coin will come out is simply number of 50 paisa coin by total number of coins. You can skip this step and directly write the number of coins. Okay, number of 50 paisa coins is 100, total number of coins is 180, so 0 0 will get cancelled. It is 10 by 8, again 2 5s are 10, 2 9s are 18, so 5 by 9 is the probability that a 50 paisa coin will come out, and will not be a rupee fine coin. So in the second case, first what we'll do is, first we'll find the probability that a 5 rupee coin will come out, probability that 5 rupee coin comes. So here this will be equal to number of 5 rupee coin by total number of coin. So number of 5 rupee coins are 10 and total number of coins is 180, so this 0 will get cancelled, 1 by 18 I will get. Now probability that it's not a 5 rupee coin, so an event where 5 rupee coin and an event where a 5 rupee coin comes and an event where a 5 rupee coin not comes, these two are complementary events. Okay, therefore when we sum up their probabilities, it will be equal to 1. Okay, probability of 5 rupee coin and probability of not 5 rupee coin, when we sum up these two, it will be equal to 1. Therefore probability that not 5 rupee coin is equal to 1 minus probability of 5 rupee coin. So we came to know the probability of 5 rupee coin, probability of an event where a 5 rupee coin comes out is 1 by 18, we checked out. So now 1 means it is 1 by 1, so now LCM of 1 and 18 is 18, so 18 minus 1 I will get, so this is equal to 17 by 18. So this is the probability of an event where a 5 rupee coin will not come out of the piggy bank. Exercise 14.1, question number 11. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out 1 fish at random from a tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? So here number of male fish is equal to 5 and number of female fish is equal to 8 fish. Therefore total number of fish is equal to 5 plus 8 is 13. Okay, therefore if one fish is picked from the tank and the probability that it is a male fish will be equal to number of male fish divided by number of total number of fish. Okay, total number of fish, so this is equal to 5 by 13. Exercise 14.1 question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3, 4, 5, 6, 7, 8, and these are equally likely outcomes. What is the probability that it will point at number 8, an odd number, a number greater than 2, a number less than 9? So here there is a wheel, and upon that there are numbers 1, 2, 3, 4, 5, 6, 7, 8, and there is a arrow, and that arrow is made to spin. After some time this arrow will stop spinning and it will point at some number here. Okay, so here possible outcomes, are 1, 2, 3, 4, 5, 6, 7 and 8. So when the arrow is made to rotate, it will come and rest on one of these numbers. Okay, so total number of numbers is equal to, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8. Total number of numbers are 8 only. Okay, now coming to first sub question. Here, what is the probability that it will point at 8? Okay, so number of 8 is equal to 1. So out of these possibilities, out of these possible outcomes, there's only one outcome where the number is 8. Okay, therefore number of 8s is 1. Therefore probability that the arrow rests on number 8 will be equal to 1 by total number of numbers is 8. So 1 by 8 is the probability. Coming to second sub question. So here an odd number. See, odd numbers are, so in the possible outcomes are 1, 2, 3, 4, 5, 6, 7, 8. What are the odd numbers out of this? 1 is an odd number, 3 is an odd number, 5 is an odd number, 7 is an odd number. So number of odd numbers is equal to 4. Therefore probability that the arrow stops at an odd number is equal to number of odd numbers divided by total number of numbers. So this is equal to number of odd numbers is 4, total number of numbers is 8. So this is 1 by 2. Next, a number greater than 2. Okay, so numbers greater than 2 are, okay, sorry, numbers greater than 2 are, what are the, in the possible outcomes, what are the numbers greater than 2? 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, 6 is greater than 2, 7 is greater than 2, 8 is greater than 2, totally 6. Okay, therefore number of numbers greater than 2 are 6. Okay, therefore probability that the number obtained is greater than 2 is equal to 6 by 8, where 6 is the number of numbers greater than 2 and 8 is the total number of numbers. So this is equal to 2 3s are 6, 2 4s are 8. So probability is 3 by 4. And the last one, a number less than 9. Okay, so numbers less than 9 are less than 9 are, so in the possible outcomes are 1 2 3 4 5 6 7 8. So in that one, what all the numbers are which are less than 9? All the numbers are less than 9. Okay, 1 2 3 4 5 6 7 8. So total number of numbers that are less than 9 are 8. So 8 possibilities are there, and all the numbers are less than 9. Okay, therefore probability that it is probability that the arrow points to a number which is less than 9 will be equal to number of numbers less than 9, that is there are 8 numbers totally which are less than 9, divided by total number of numbers. Total number of numbers are 8, so 8 by 8 is 1. So this is actually a sure event. Exercise 14.1, question number 13. A dice is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, an odd number. So in this question, in throwing a dice experiment, what are the possible outcomes? So possible outcomes are 1 2 3 4 5 and 6. These are the possible outcomes that we get when we throw a dice. So what are the total number of outcomes? So how many outcomes are there? 1 2 3 4 5 6. Total number of outcomes are 6. Now coming to the first question, what is the probability of getting a prime number? So prime numbers are so out of the possible outcomes, what are the prime numbers? 2 is a prime number, 3 is a prime number, 5 is a prime number. Therefore number of prime numbers is equal to 3, 2 3 and 5. Therefore probability that the prime number occurs is number of prime numbers divided by total number of outcomes. So this is equal to 3 by 6. 3 by 6 is equal to 1 by 2. Coming to second sub question, the number lying between 2 and 6. Okay, numbers lying between 2 and 6 are, what are the numbers lying between 2 and 6 between, what are the numbers lying between 2 and 6 among the possible outcomes? Among the possible outcomes, the numbers lying between 2 and 6 are 3, 4 and 5. Therefore number of numbers lying between 2 and 6 is equal to 3. There are 3 numbers which are lying between 2 and 6. Therefore probability that the number lies between 2 and 6 is 3 by 6. Okay, 3 is the number of numbers lying between 2 and 6. 6 is the total number of outcomes. Similarly, third sub question, an odd number. Okay, the odd numbers are, so in the possible outcomes, what are the odd numbers? 1 is an odd number, 3 is an odd number and 5 is an odd number. Therefore number of odd numbers is equal to 3. Therefore probability of that an odd number occurs is equal to number of odd numbers divided by total number of outcomes. So this is equal to 3 by 6. 3 by 6 is 1 by 2. And that completes this problem. Exercise 14.1, question number 14. One card is drawn from a well shuffled deck of 52 cards. Okay, many of you won't be knowing what this deck of 52 cards contain. I'll be explaining you. So this deck of 52 cards contain 4 groups of cards, and those 4 groups are club, spade, diamond and hearts. And this club and spade will be of black in color, and the diamond and hearts will be of red in color. The club cards contain ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and jack and queen and king. So this totals up 13. Similarly, in spade also it is ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen and king, totaling 13. So similarly, in diamonds also there are 13 cards, and in hearts also there are 13 cards. So this totals up to 52. So this deck of cards are shuffled and one card is picked out, and now what is the probability that the picked card is a king of red? That's the first sub question. Okay, so here you can see here how many red cards are there which are king. There are 2. One is king diamond and one is heart diamond. Therefore there are 2 kings of red color. Okay, therefore probability of king which are red in color is equal to, so there are 2 cards which are red and the total number of cards are 52. So it is now 2 1s are 2, 2 2s are 4, 2 6 are 12. So probability of picking a king card which is red is 1 by 26. Second sub question, a face card. So the face cards are jack, queen and king. Okay, these are the face cards, jack, queen and king. So in club there are 3 cards, and in spade there are 3 cards, and similarly in diamond and hearts also there are 3 cards. Therefore number of face cards is equal to 3 into 4 is equal to 12. Therefore probability that a face card is picked is equal to 12 divided by total number of cards, that is 52. So here we can simplify. Okay, it is divisible by 4. 4 3s are 12, 4 1s are 4, then 4 3s are 12, so 3 by 13. Third sub question, what is the probability that a red face card is picked? So you can see the red face cards are there in diamond and hearts. In diamonds there are 3 red face cards, and in hearts there are 3 red face card. Therefore number of red face cards is equal to 2 into 3 is equal to 6. Okay, therefore now probability that a red face card is picked is equal to 6 divided by total number of cards, that is 52. So you can simplify this. It is divided by 3. 2 3s are 6, 2 2s are 4, then 2 6s are 12. The fourth sub question, what is the probability that jack of hearts is picked? Okay, now you can see jack of hearts. Okay, in hearts here you can see jack is only 1. Okay, therefore number of jack of hearts is equal to 1. Therefore probability that a jack of hearts is picked will be equal to 1 divided by total number of cards, that is 52. So 1 by 52 is the probability. Fifth sub question, what is the probability that a spade card is picked? So you can see the number of spade cards are 13. So in spade there are 13 cards. Therefore, number of spade cards is equal to 13. Okay. Therefore, probability that a spade card is picked is equal to 13 divided by total number of cards, that is 52. So is it divisible by any common number? So it is divisible by 13. 13 ones are 13, 13 fours are 52. The fourth sub question, the sixth sub question, what is the probability that the queen of diamonds is picked? So here you can see in diamond, this is the diamond cards. So here how many queens are there? We can see there is only one queen, which is a diamond. Therefore, number of queen of diamonds is equal to 1. Therefore, probability that a queen of diamond is picked is equal to 1 divided by total number of cards. So 1 by 52 is the probability. For any of the playing cards problem in future, you can use this this problem as a template. Exercise 14.1, question number 15. 5 cards, the 10, jack, queen, king and ace of the diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is queen? If the queen is drawn and put aside, what is the probability that the second card picked up is an ace and a queen? So here there are 5 cards. Cards are 10, jack, then queen, king and ace. There are number of cards. Number of cards is equal to 5. Okay. Now first one, what is the probability that the card is queen? So how many queen are there in this one? Only one queen is there. Therefore, probability of picking a queen is equal to 1 by total number of cards, that is 5. Okay. Now in the second sub question, A. So before that, the queen, if the queen is drawn and put aside, okay, the cards now are, so queen is taken out and put aside, right? So the cards now left are 10, jack, king and ace. So number of cards is equal to 4 now. Now only 4 cards is there. Now in this 4 card, what is the probability that the card picked is ace? So here in these 4 cards, how many ace are there? Only one ace is there. So 1 divided by total number of cards, that is 4. Next, what is the probability that a queen is picked now? Now there is no queen here. 10, jack, king and ace is there. There is no queen. So what is the probability of picking a queen? It's 0. So 0 queen cards are there. 0 by total number of cards, that is 0. 0 by 4 is equal to 0. Exercise 14.1, question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So here defective pens, number of defective pens are 12, and good pens, number of good pens is equal to 132. Therefore total number of pens is equal to 2 to 4, 3 plus 1, 4. So total number of pens is equal to 144. Therefore, probability out of 144 pens, the probability that the good one is taken out is probability of picking a good pen is equal to number of good pen divided by total number of pens. You can skip this to this sentence and directly write as number 132 by 144. Just for your understanding, I have written. So you can simplify. You can divide by 2. 2 6 are 12. Then 2 6 are 12. 2 7s are 14. 2 2s are 4. Again you can divide by 2. 2 3s are 6. 2 3s are 6. 2 3s are 6. 2 6 are 12. Okay, again you can divide by 3. 3 11s are 33. 3 12s are 36. Exercise 14.1, question number 7. A lot of 20 bulbs contain 4 defective bulbs. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? So total bulbs is equal to 20, and out of this defective bulbs is equal to 4. Therefore, defective bulbs will be equal to 20 minus 4 is equal to 16. Now, total bulbs are 20, defective bulbs are 4. Now, if I pick a bulb from this lot, what is the probability that a defective bulb is picked? Okay, that's the question. So probability that a defective bulb is picked will be equal to number of defective bulbs divided by total number of bulbs. You can avoid writing this sentence, you can directly write the numbers. So here it is 4 by 20 is equal to 1 by 5. 4 ones are 4, 4 5s are 20. Now coming to the second sub question. Suppose the bulb drawn in 1 is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? So after situation 1, what is the number of defective bulbs left? Number of non-defective bulbs left. Okay. Number of non-defective bulbs left. See, in first case, one bulb is drawn and that bulb is not defective, they are telling. Okay, suppose the bulb drawn in 1 is not defective, okay, and is not replaced. Therefore, now the total number of defective bulbs left will be 16 minus 1 is equal to 15. Okay, and after situation 1, total number of bulbs left is equal to 20 minus 1 is equal to 19. Okay, now again if I pick a bulb, okay, again if I pick a bulb, what is the probability that I'll pick a non-defective bulb? That's the question. So in first case, one bulb was taken and that bulb happens to be non-defective and that bulb is not replaced, and after that 15 non-defective and 19 total bulbs are left. Now the probability that a non-defective bulb will be picked will be equal to number of non-defective bulbs divided by total number of bulbs. You can avoid this sentence. Directly you can write the numbers. So now the number of non-defective bulbs is 19. Total number of bulbs left, number of non-defective bulbs left is 15. Total number of bulbs left now is 19. So 15 by 19. So we can't simplify this one. 19 is a prime number. So 15 by 19 is the answer. Exercise 14.1, question number 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square number, a number divisible by 5. So I think the question is clear. There are 90 discs which are numbered from 1 to 90, and one disc is drawn randomly. Okay, now here how many 10-digit numbers are there? You can see from 11 to 20 there are 10 numbers which are 2-digit numbers. Okay, and again from 21 to 30 there are 10 digits there are 10 numbers which are 2-digit. Again from 31 to 40 there are 10 numbers which are 2-digit numbers. Okay, similarly here there are 10 numbers, 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 and 10 is also a 2-digit number. So here only 1 is there. Okay, so if we sum up all this, how much we get? This is 1 2 3 4 5 6 7 8. So 8 plus 1, 81. Okay, 81 two-digit numbers are there. Okay, now coming to the first sub question. What is the probability that a 2-digit number is drawn? So probability that a 2-digit number disk is drawn. So this will be simply equal to number of 2 digits. Number of 2 digits number. Number of 2 digits number divided by total number of rings. So what is the, how many 2-digit numbers are there? Totally there are 81. Okay, 81. And what is the total number of rings? That is 90. So now 9 9s are 81, 9 10s are 90. So 9 by 10 is the probability. And the second sub question. What is the probability that I get a perfect square number? So here how many perfect square numbers are there here? Now 2 is a perfect square number, 4 is a perfect square number, because 4 is equal to 2 into 2, and also 9 is a perfect square number because 3 into 3 is 9, and what about 16 also is a perfect square number, so 4 into 4 is 16, and 25 is 5 into 5, and 36 is 6 into 6, and so 49 is equal to 7 into 7, and 64 is equal to 8 into 8, then 81 is equal to 9 into 9. So also 1 is a perfect square number because 1 is equal to 1 into 1. So totally how many perfect square numbers are there? 1 2 3 4 5 6 7 8 9. Okay, therefore probability that I get a perfect square number, perfect square number is equal to number of perfect square numbers divided by total number of rings. So number of perfect square is how much It's 9. Okay, 9 total number of rings is 90. So this is 1 by 10. 9 ones are 9, 9 tens are 90. And the last question, a number divisible by 5. So which all digits are divisible by 5? So 5 is divisible by 5, 15 is divisible by 5, then 25 is divisible by 5. So all the numbers in this row are divisible by 5. So how many are there totally? So 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8 9. So therefore 9 numbers which are divisible by 5 in this row. Similarly, 10 is divisible by 20, is divisible by 5, 30 is divisible by 5. All these numbers in this row are divisible by 5. So here also there is 9 numbers. So probability that I'll get a number divisible by 5 is equal to, so number of numbers divisible by 5 divided by total. So number of numbers divisible by 5 is 9 plus 9 by total number is 90. So 18 by 90. So here 9 2s are 18, 9 10s are 90. Then 2 1s are 2, 2 5s are 10. 1 by 5 is the answer. Exercise 14.1, question number 19. A child has a die whose 6 faces show the letter as given below: A, B, C, D, E and A. The die is thrown once. What is the probability of getting A and D? Okay. Now in this dice, number of faces. What is the number of faces? So totally there are 6 faces. And what are the number of A faces? There are 2A. Okay, 2A faces are there. And what is the number of D faces? Number of D faces is equal to 1. Only 1 D is there. Now coming to first sub question, what is the probability that after throwing a dice, A is appearing? So this will be equal to simply number of A faces divided by total number of faces. So this is equal to, so number of A faces is 2. Okay, so this is 2 divided by 6. 2 1s are 2, 2 3s are 6. Now second sub question, and what is the probability that after throwing a dice, the D face is coming? So this will be number of D faces divided by total number of faces. You can skip writing this sentence and save time in exam. Directly we can write the numbers here. That is 1 by 6. So probability that A occurs is 1 by 3 and probability that D occurs is 1 by 6. Exercise 14.1, question number 20. Suppose you drop a die at random on a rectangle region shown in figure 14.6. What is the probability that it will land inside the circle with diameter 1 meter? So the rectangular region is of dimension 3 meter by 2 meter and there is a circle inside it of diameter 1 meter. Now if I throw a dice, what is the probability that the dice will fall inside the circular region? That's the question. So probability will be now will be equal to area of circle divided by area of rectangle. So area of circle is given by pi r square. So here What is the area of rectangle given by length into breadth? So this is equal to pi. So what is the radius of the circle? It is 1 by, so diameter is 1 meter, so half of that is radius, so 1 by 2 the whole square by, here what is the length? Length is 3 meter, breadth is 2 meter. Okay, so this is equal to pi into, so 1 by 2 into 1 by 2, and so 3 into 2, so 3 into 2 I can write as, so pi half, pi into 1 by 2 the whole square, 3 to the 6, so 6 means it is 6 by 1. So now I can take to the numerator, 6 by 1 becomes 1 by 6. Now 2 to the 4, 4 6 are 24, so pi by 24, sorry, pi by 24 is the answer. The probability that the dice thrown will fall on the circle is pi by 24. Okay. 14.1, question number 21. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it, and what is the probability that she will not buy it? So here, number of pens, number of ball pens is equal to 144. Okay, and number of defective ball pens is equal to 20. Therefore, what will be the number of non-defective pens? Okay, number of non-defective ball pens will be equal to 144 minus 20, which is equal to 124. Okay, now what is the first sub question? Now the shopkeeper takes a pen and she gives to Noori, whether Noori will buy it or not. So probability that Noori will buy will be equal to probability of non-defective ball pen. Okay, so probability that Noori will buy pen is equal to probability that the picked up pen is a non-defective pen. So probability of picking a non-defective pen will be simply equal to number of non-defective pen divided by total pens. So what is this? Number of non-defective pens. What is the number of non-defective pens? It is 124, and total number of pens is 144. So you can simplify this one. 2 6 are 12, 2 2s are 4, 2 7s are 14, 2 2s are 4. Again you can simplify. 2 3s are 6, 2 1s are 2, 2 3s are 6, 2 6s are 12. So 31 by 6 is the probability. Now what is the probability that Noori will not buy? So probability that Noori will not buy will be the probability that the picked up pen is a defective pen. So probability of defective pen. So this is equal to number of defective pen by total number of pens. So what is the number of defective pens? Number of defective pens is 20. Total number of pens is 144. So if we can simplify, 2 10s are 20, 2 7s are 14, 2 2s are 4, then 2 5s are 10, 2 3s are 6, 2 6s are 12. So it is 5 by 36. Exercise 14.1, question number 22. Refer to example 13. Complete the following table. So in example 13, the two dice are thrown at the same time. So see, you can see here two dice, one blue and one gray, are thrown at the same time. So this is blue dice, this is a gray dice, they are thrown simultaneously. So these are the possible outcomes. So how can we write it in a simple way? So I'll show you. Now if the first dice shows up 1, the second dice may also show up 1. Similarly, for the first dice 1, second dice may show up 2. So similarly 1 comma 3, 1 comma 4, 1 comma 5 and 1 comma 6. Similarly for the first dice showing up 2, the second may show 1. So 2 comma 1, now 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5 and 2 comma 6. So similarly 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. So now you can see I have written all the possible outcomes. So here you can see there are 6 columns and 6 rows. Okay, therefore total possible outcomes is 6 into 6 is equal to 36. Now coming back to question, so they have asked to fill up the table. Okay, and the table is like this. So the table is all full of probabilities. Okay, we should find the probability of event where sum of the two dice is equal to 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now here you can see probability of getting sum of two faces of dice is 2. So here you can see this is the only outcome where the sum of the faces are 2. So that's why probability will be equal to 1 by total number of outcomes, that is total number of outcomes is 36. And also they have given the probability of getting 12 is 1 by 36. So here you can see 6 comma 6 is the outcome where we get sum equal to 12. Therefore there are only one outcome. Okay, that's why probability of 12 is 1 by total number, that is 1 by 36. And given the probability of getting 8 is 5 by 36. Okay, so 8, where are we getting 8? So you can see 4 comma 4. Okay, all these are outcomes where we get sum equal to 8. So how many outcomes are there? 1, 2, 3, 4, 5. There are 5 outcomes. Therefore 5 divided by total number, that is 36. So 5 by 36 is the probability of getting 8. So similarly, what is the probability that we get 3? So you can see here we get 2 outcomes where the sum is equal to 3. Therefore 2 by 36 is the probability of getting 3. Similarly, what is the probability of getting 4? Here you can see there are 3 outcomes, that is 3 by 36. Probability of getting 4 is 3 by 36. Similarly, probability of getting 5 is this one, 1, 2, 3, 4. There are 4 outcomes where we get 5. Okay, so 4 by 36 is the probability of 5. So probability of 6 is this. So totally how many? 1, 2, 3, 4, 5. There are 5 outcomes where we get sum equal to 6. So 5 by 36 is the probability of 6. Similarly, these are the outcomes where we get 7. 1, 2, 3, 4, 5, 6. There are 6 outcomes. So 6 by total number, that is 36. Now what is 9? Probability of getting 9, that is here. So 1, 2, 3, 4. There are 4 outcomes. Therefore 4 by 36 is the probability of getting 9, and probability of getting 10 is this. Three outcomes are there, so 3 by 36, and probability of getting 11 is 2 by 36. The next sub question, a student argues that there are 11 possible outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore, each of them has a probability of 1 by 11. Do you agree with this argument? No. Okay, so the argument is no. So y means there are 36 possible outcomes. So you can see the list there. It's not 12 outcomes, there are 36 outcomes. Okay. Example, probability of getting 3. Probability of getting 3 is 2 by 36. Okay. Why? Because 1 and 2 and 2 and 1 are different outcomes. Okay. Similarly, we can argue for many events here. Okay, probability of getting 4 is 3 by 36, probability of getting 5 is 4 by 36, and so on. It's not 1 by 11 as told by the student. That student is telling the probability of all these outcomes are just 1 by 11. It's not so. Okay, you can see in the table the probability of getting 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 all are different. Exercise 14.1, question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So here 1 rupee coin is tossed 3 times. So possible outcomes are when a coin is tossed 3 times. So we may get 3 times head, or we may get head tail, then head tail head, then head tail tail, then tail head head, then tail head tail we may get, then we may get tail head, then tail tail we may get. So these are the 8 possibilities. Okay, totally there are 8. Okay, Hanif will win. Okay, when he is going to win? Only when if the toss gives the same result, that is 3 heads. Okay, Hanif will win when 3 heads will come, and Hanif will win if 3 tails will come. Okay, in these 2 cases only Hanif will win. In all the other cases Hanif will lose. So what are the total possibilities? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. 8 possible outcomes. Okay. Number of possible outcomes is equal to 8. Okay, then in how many outcomes there are no 3 head and no 3 tails? Okay, here you can see there are 6 outcomes where there are no 3 heads and 3 tails. Okay, no 3 head or no 3 tails. So there are 6 outcomes. Okay, therefore Hanif, probability that Hanif will lose. Okay, when he loses, when he won't get 3 heads or 3 tails. Okay, that will be equal to 6 by 8. So that is 2 3 are 6, 2 4 are 8. So the probability that Hanif will lose is 3 by 4. This question can be solved in another method also. I'll show you. So here what we'll do is we'll calculate what's the probability that Hanif will win. Okay, here how many 3 heads? How many 3 heads or 3 tails are there? So there are 2. Okay, in the first you can see there are 3 heads, and in the last also you can see there are 3 tails. So 3 heads or 3 tails is 2 number of outcomes. Okay, where 3 heads are there or 3 tails are there. Therefore Hanif will win. Probability that Hanif will win will be equal to 2 by 8, which is equal to 1 by 4. So probability that Hanif will win and probability that Hanif will lose will be equal to 1, because these two are complementary events. Therefore probability that he will lose is equal to 1 minus probability that he will win. So this is equal to 1 minus 1 by 4. So 1 means it is 1 by 1. So if we take LCM, it is 4 by 4 minus 1 by 4. So this is equal to 4. In the numerator 4 minus 1. This is equal to 3 by 4. So you can see here and here we got same answer. Exercise 14.1, question number 24. A dice is thrown twice. What is the probability that 5 will not come up either? 5 will come up at least once. So when dice are thrown twice, all the possible outcomes have written here. It is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and at the last here 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So there are totally 6 columns by 6 rows. So total possible outcomes are 6 into 6 is equal to 36. Now what is the probability that when dice is thrown twice, what is the probability that 5 will not come up either time and 5 will come up at least once? First I will solve the second sub question. Okay, 5 will come at least once. Okay, now here you can see where all 5 is coming. Here 5 is coming in this row, and also in this column it is coming. Okay, at least one times 5 is coming. So totally if you count, so number of times 5 is appearing at least once is equal to 11. There are 11 possible outcomes where 5 is appearing at least once. Therefore probability that 5 will come at least once is equal to 11 divided by total number of possibilities. Total number of possibilities is 36. Now first sub question, 5 will not come up either time. Okay, so here you can see in all the rest of the cases 5 is not coming. Okay, so if you manually count, it will come up 25 times. Okay, number of times 5 is not appearing is equal to 25. Therefore probability 5 is not appearing either time is equal to 25. Therefore probability that 5 is not appearing either time is equal to 25 by 36. Actually these two events are mutually complementary events. Okay, that means if we add the probability of these two, it will be equal to 1. So actually if we know the one, we can find the value of other. Okay, in this first I found out second sub question. So first question I could have also done it by subtracting the probability of one of the first second sub question from 1. Exercise 14.1, question number 25. Which of the following arguments are correct and which are not correct? Give reasons for your answer. If two coins are tossed simultaneously, there are 3 possible outcomes: 2 heads, 2 tails, or one of each. Therefore for each of these outcomes the probability is 1 by 3. So whether this is correct or not, so let us check. Now when two coins are tossed, when two coins are tossed, the possible outcomes are, so in both the coins head may come, or in one coin head may come, in another coin tail may come, or in first coin tail may come and in the second coin head may come, or in both the coin tail will come. So these are the 4 possible outcomes. Okay, therefore number of possible outcomes is equal to 4. 1, 2, 3, 4 are there. Okay, now what is the possibility that 2 heads will come? Okay, now you can see out of these 4 possible outcomes, how many 2 heads are there? Number of heads, number of both heads. Okay, both heads is equal to, there is only one outcome where there are both heads. Okay, therefore probability that 2 heads will come, will be equal to 1 by 4. Okay, and similarly number of 2 tails, so possible outcomes are head, tail head, and tail. So in that one, in how many outcomes there are 2 tails? It's only 1. Okay, number of 2 tails is equal to 1. Therefore probability that 2 tails will come is equal to 1 by 4. And what is the probability that 1 tail will come or 1 head will come? Okay, so here number of 1 head or 1 tail. Okay, so you can see that there are 2 outcomes where there is 1 head and 1 tail. Okay, therefore probability that 1 head and 1 tail is coming is equal to 2 by total number, that is 2 by 4. This is equal to 1 by 2. Okay, And the second sub question, so here, is this correct or not, which of the following arguments are correct and which are not correct. So this is not correct. Okay, so in the question they are given the probability of getting two head is 1 by 3 and probability of getting 3 tails and the probability of getting 1 head 1 tail is 1 by 3. That they were given. Okay, but it is not correct. So actual probability is for 2 heads it is 1 by 4, for 2 tails it is 1 by 4, and for 1 head and 1 tail is 1 by 2. The next sub question. So if a die is thrown, there are 3 possible outcomes, an odd and an even number. Therefore the probability of getting an odd number is 1 by 2. So here, for dice throwing experiment, possible outcomes are, what are the possible outcomes? Possible outcomes will be 1, 2, 3, 4, 5 and 6. Okay, and the probability of getting an odd number or an even number is 1 by 2. That's the given data. Is it correct or not, they are asking. So here, number of heads. Okay, what is the total number of outcomes? Total number of outcomes is equal to 6. Now out of these 6 outcomes, number of heads is equal, number of odd numbers is equal to 3, and number of even numbers is equal to, they are also 3. What are the number of odd numbers? 1, 3 and 5 are the odd numbers, and even numbers are 2, 4 and 6. Okay, now what is the probability that I get an odd number? It's simple. Number of odd numbers divided by total number. So this is equal to how much? 3 by 6. This is equal to 1 by 2. Similarly, probability of even number is equal to number of even numbers divided by total number. Here also number of even numbers are 3. Okay, and total number of numbers are 6. So this is equal to 1 by 2. So the given data is correct. If a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore the probability of getting an odd number is 1 by 2. So that sentence is correct. And here in this problem you can make one observation, that getting an odd number and getting an even number, they are complementary events. Okay, whenever we get odd number we won't get even number, whenever we get an even number we won't get an odd number. Therefore probability of odd plus probability of even will be equal to 1 by 2 plus 1 by 2. 1 by 2 plus 1 by 2 is equal to 1. So this is not required actually, just for your understanding I am explaining you. Our answer ends here only at this point. And that completes this exercise and this chapter. The next topic is optional exercise. So optional exercise, they are out of scope for 10th standard. They are given here. These exercises are not from the examination point of view. So these questions will not come for examination, but you can try it by yourself. Just for your understanding sake they have given you. If you want you can try and solve all this. And the next is summary. In this chapter we have studied the following points. So the difference between experimental probability and theoretical probability. So experimental probability may be slightly different from theoretical probability, but if there is a high number of trial done, then the practical probability also will be equal to theoretical probability. For example, if you toss a coin for 10 times, 4 times you may get head and 6 times you may get tail. So what is the probability of head? It will be 4 by 10. What is the probability of tail? It will be 6 by 10. But if you toss the coin for 10,000 times and if you check the probability, then you get probability of head and probability of tail to be equal only. It will be equal to 1 by 2, 1 by 2, almost equal to 1 by 2, 1 by 2. Okay. And probability of an event is defined by simply by the ratio of favorable number of outcomes by possible number of outcomes. And probability of a certain event is equal to 1. For example, in a dice throwing experiment, what is the probability of getting a number which is less than 7? So probability of that event will be equal to 1, because no matter how many times you throw the dice, you get a number which is always less than 7. Therefore probability of getting 7 in a dice throwing experiment is equal to 1. That means probability of a certain event is 1. And probability of an impossible event is equal to 0. For example, in a dice throwing experiment, can we get number 8? No, we can get only 1, 2, 3, 4, 5, 6. Therefore an event of getting 8 in a dice throwing experiment is impossible. That means probability of getting 8 is equal to 0. The event which cannot occur is an impossible event. And probability of any event is greater or equal to 0 and lesser than or equal to 1. Okay. And coming to elementary event, an event having one outcome is called an elementary event. For example, in a dice throwing experiment, an event of getting 1 and an event of getting 2 and an event of getting 3 and an event of getting 4 and an event of getting 5 and an event of getting 6, all these are elementary events. And when we add the probability of all the elementary events, we will get 1. For example, here probability of getting probability of 1 is 1 by 6, probability of 2 is 1 by 6, probability of 3 is 1 by 6, and if we add all the probabilities, we get 6 by 6, which is equal to 1. Similarly, in a coin tossing experiment also, probability of getting a head and getting a tail, these two are elementary events. So when we add the probability of getting head and probability of getting tail in a coin tossing experiment, we get sum equal to 1. Okay. And if E and not E are complementary events, then the probability of those two events will be equal to 1. Again, here what example can we give? Again, it's the coin tossing experiment. In a coin tossing experiment, getting a head and getting a tail, these two are complementary events, because when one occurs, the other can't occur. Whenever we get head, we can't get tail. Whenever we get tail, we can't get head. That's why getting a head and getting a tail are complementary events to one another. Okay. So probability of sum of probability of complementary events is equal to 1, and that completes the summary and this chapter.